In this video, let's learn the logic of regression discontinuity. If you need to implement a regression discontinuity, I recommend you to study this book here, A Practical Introduction to Regression Discontinuity. It was published in 2020, and the book relies on this paper published in Econometric, written by Eric Meyerson. I will use the data for this paper for my exposition. The Y here is the proportion of females that completed the high school in Turkey. Each blue ball here is one city in Turkey. The X is the Islamic win margin that was normalized to 0. Above 0 is where the Islamic party won the election, and below 0 is where the secular party won the election. That means the right side is the treatment group, the municipalities governed by Islamic major, and the left side is the control group, the municipalities governed by the secular major. If you take the mean of these blue balls, we get that the Y-bar treatment is equal 14%. That means 14% of females complete high school in Turkey. In the control group, the proportion is higher, 16.6%. Many people see these statistics and conclude that the Islamic religion is the cause of this poor outcome, that it limits the rights of the females. This is what I call naive comparison. It is not fair to compare a municipality where the Islamic part won by 100% with a municipality where the Islamic part lost by 100%. The municipalities governed by the Islamic party, they are more likely to be rural and poor than the municipalities governed by the secular party. This difference here might be driven by poverty and not religion. The fair comparison is to compare the municipalities around the cutoff 0, because around this cutoff, the municipalities are likely to be equal. Barely win or lose, it's like a random process, like flip a coin. I plot this graphic if you aggregate data. The data is the same of this graphic here. Here I combine the municipalities that they have similar Y, and the size of the blue ball is proportional to the number of municipalities. The goal of this data aggregation is to see that there is a discontinuity in the cutoff here. Let's aggregate the data a little bit more and zoom the cutoff. If I fit a line to the treatment group and the control group and get the difference between the intercepts, we get that 3.5 more females completed the high school in the Islamic municipalities. How credible is this result comparing to the naive comparison? In the naive comparison, we use the full sample, and this is the statistics based on full sample. 0 here is the control group, and 1 is the treatment group, the Islamic municipalities. This is the Islamic voting share in 1994. See that in the control group only 10% against 41%. That is huge. Now, let's restrict the sample size to 5% around the cutoff. See that the Islamic voting share now is 0.3 against 0.35. In an experiment, you expect that this difference to be smaller, but it is not that bad comparing to the naive comparison. If you see big difference, you wanna add these as control variables in the regression discontinuity framework. See that in the Islamic municipalities, for the full sample, the household is bigger, 6.4 people, against 5.7. In the proportion of younger people, it's bigger as well, 0.44 against 0.39. But when you go to the regression discontinuity framework, you see that the treatment and the control are pretty similar. Pretty much everywhere, you can see that the high level of religiosity, it's related with poor education outcome. You can see this in Europe, Latin America for Catholics, but the point is, it might be just a spurious correlation. You might argue we should not fit a line with 5 data points with a bandwidth of 27%. Here we have the result for bandwidth 5%, and see that the impact is even higher, 4%. With disaggregate data In the very narrow cutoff, we see that the Islamic Party increases in 4% the proportion of females that complete the high school.